Okay, we're going to go through the last unit assessment to help you prepare for your retest. On the first question, we were told that segments that look like mid-segments are indeed mid-segments. So FD does look like a mid-segment, as does FB and BD. We'll start out with the given information that we have. We're told that FB is 12, so we'll put a 12 in for FB. AE is 16, so 16 for AE. And FD is 9, FD is 9. Now we're told that 2 times the mid-segment is equal to the third side. So since FB is 12, EC has to be 12 doubled, it has to be 24. And since FD is 9, you double 9, we get 18 for AC. And then BD we don't know, but we do know if we double it, we get 16. So that means BD has to be 8. 2 times the mid-segment equals the third side. 2 times the mid-segment equals the third side. 2 times 9 is 18. 2 times 8 is 16. 2 times 12 is 24. On this next question, again, we have mid-segment, so AB is a mid-segment. And 2 times the mid-segment, 2 times 2x, is equal to the third side, x plus 6. So 4x equals x plus 6. 3x is 6. X would be 2. Now, since it is a mid-segment, B is a midpoint. So that means the 2 values have to be equal here. So 10z minus 16, the part above that, has to equal 3z plus 5. If we subtract 3z from both sides, and we saw a lot of algebra mistakes, people set it up, but end up with 13z over here instead of 7z. Add 16. 7z equals 21, so z equals 3. And then on the other side, since it's a mid-segment, A is a midpoint, so these 2 pieces are congruent. So 4y plus 1 has to equal 6y plus 11. Minus 11, excuse me. Let's try rewriting that. 4y plus 1 equals 6y minus 11. Subtract 4y, subtract 4y. 1 is 2y minus 11. Add 11. Y is 6. So again, 2 times the mid-segment equals the third side. And if a point is a midpoint, it divides it into 2 equal pieces. This one is straight vocabulary, knowing where points meet. The angle bisectors meet at the center. You're just going to have to find some way to memorize these pairings. Perpendicular bisector meets at the circumcenter. If these are on the retest, they'll be in a different order, so you're definitely going to have to memorize that the altitude is the orthocenter and that the median is the centroid. Tell you what, just memorize 3 of them. And the 4th one is going to be the one that's left over. Would be a possible way you can deal with this. Here, the centroid. The idea is that in this case, the centroid is broken into the ratio of 2 to 1. So the longer piece is 2 times the shorter piece. So in our diagram, we know that AG is 10. That's the long piece, so the short piece, GE, has to be 5. So GE or EG is 5. And then AE, the total piece, is going to be 10 plus 5, or 15. Next, BD. Well, these are medians. This is a midpoint, so these 2 sides are both the same, so BD would have to be 8. BD would have to be 8. And we're told that CD is 18. So the total distance is 18. This total piece is 18 in green. Then the two pieces added together have to give us 18. We have our short one and the one that's twice as long, so x plus 2x has to equal 18. 3x is 18, so x is 6. And we want to know dg, and dg happens to be the x, so it would be 6. Another one that's based upon knowing vocabulary. They want to place a recycling bin so it's the same distance from the snack bar and the volleyball court and the lifeguard chair. So those are the corners or the vertices. The points at the same distance from each of the vertices is called the circumcenter. The circumcenter is the same distance from each vertice. The incenter is the same distance from each side of the triangle. Triangles have 4 different types of centers: incenter, circumcenter, etc. All right, in this proof, first I'm going to go through the given. QS bisects PQR. Well, it's right here, so that's given. And the other given is SP is perpendicular to QP. Oh, that's right here. There's our two givens. So our given has been used. Now, since there is a gap between the given, that means that statement number 2 must follow from statement 1. And statement 1 says that QS bisects PQR. So QS takes PQR and separates it into 2 equal pieces. These 2 pieces. So we'll look for those 2 angles. We have angle PQS and angle RQS. And we have angle SQP and RQS. Now, those are both ways to name them. However, this first one is the better way to name them. So it would be the one that we pull over there, although I did give credit for the other one. So angle PQS is congruent to angle RQS. And our reason is the definition of an angle bisector. An angle bisector creates 2 equal angles. Moving on from the other part, we want number 3, we're talking about all these perpendicular lines. Well, first thing is perpendicular lines form right angles. All this statement here about right angles is going to go in there. Identifying QPS and QRS as right angles. Now, if they're right angles, they're going to be congruent to each other. So now we come down here to those 2 angles. Angle QPS is congruent to angle QRS. In our reason, all right angles are congruent. So in the previous step, we said they were right angles. Now we can say they're congruent. Reflexive property is something is congruent to itself. The only thing we have over there like that is QS. So this should have been give me point because that's all we have, QS. And if we mark our picture, we can see we have 2 angles and a side of both triangles, but the side is not between the 2 angles. So our reason is angle, angle, side. We need to name the 2 triangles. So we, excuse me, we have these choices. We need to name them in such a way that pieces match up, and that would be QRS and QPS. And then finally, we talked about 2 pieces of them, SP and SR, and so that would be corresponding parts of congruent triangles are congruent. Remember, things have to flow in order from the given, what follows next, and then from this what statement we have, what comes next out of it. This part, anytime we're talking about triangles being congruent, we're going to have something like angle, angle, side, etc. This was the only choice. We didn't have any side, angle, side to choose. And then finally, corresponding perpendicular bisector. Perpendicular bisector means it's the same distance from each of the sides. So EH and FE are the same. This one we did quite well on part A, mainly because this is about the only thing we might think to do. 6x equal, 19 equals 6x minus 5. So 24 equals 6x. So 4 equals x. And then angle HGE is 9z. HGE, this angle right here, is 9z. Well, it's also a right angle, so it's 90 degrees. So z has to be 10. Because it's perpendicular, it has to be a right angle in there. So for it to be a right angle, z has to be 10. Another know your terms. Equidistant from every vertex. That's the circumcenter. Equidistant from every side. That's the incenter. Which point is the center of an inscribed circle in a triangle? That's the incenter. Which point is the center of a circumscribed circle about the triangle? That's the circumcenter. You have the key circum as keyword. Which points are always on the inside? Well, the centroid's always on the inside, and so is the incenter. Which points are always on the outside of an obtuse triangle? Well, it'd have to be the other two, because if these two are always inside, they're never going to be outside. And since we're looking for points, we must choose more than one. So that leaves orthocenter and circumcenter. Center of gravity is the centroid. Memorize these characteristics. This will show up again. And then finally, triangle ABC has these coordinates. Find the centroid of the triangle. M is the midpoint of BC. So B is 2, -2. C is 6. Find the midpoint. We add the x's. Divide by 2. That gives us 7. Add the y's. Divide by 2. That gives us 2. So the midpoint is 7, 2. Find the centroid. Well, the centroid is going to be on a median, and the median will go from A, which is 411, to M, which is 7, 2. From a vertex to a midpoint. We're doing a centroid, so a centroid is always a 2-to-1 ratio. So we'll want to break it off into 3 stairs of the same size. Find out our vertical and horizontal change. Going from 4 to 7 is a change of 3. Going from 2 to 11 is a change of 9. So our right triangle has sides of 9 and 3. So each step is going to be 3 divided by 3. It's going to have a horizontal change of 1. And 9 divided by 3, a vertical change of 3. We're dividing by 3 because it has to be a 2-to-1 ratio. So here is our point F. We go to our 2-to-1 ratio, so 2 steps from the top, 1 step from the bottom. 2 steps from the vertex. 2 steps from the vertex, 1 step underneath. So our x has to change by 1. So 7, go back 1, we get 6. And 2, go up 3, it takes us to 5. So 6, 5 is the centroid. To find the length from A to F, A to F would be this piece here. We draw on the triangle, the right triangle. X goes from 4 to 6, so it changes by 2. Y goes from 4 to 11, so it changes by 6. So AF is going to be 2 squared plus 6 squared. Take the square root of that. 4 plus 36 is 40, the square root of 40. That's going to be about 6.4. We do the same thing to find out FM. That's going to be this little triangle down here. To go from 6 to 7 is 1. To go from 2 to 5 is 3. And the triangle 1 by 3, so 1 squared plus 3 squared. Square root of that is going to give us FM. Square root of 10, which is about 3.2 when we round it. So those are all your questions. Make sure you study those. Good luck and see you test time.